Hi guys, welcome to my channel. So it's a day 4 for the Cisco Catalyst SD-WAN series. So today we are going to cover the Cisco Catalyst SD-WAN terminology. So let's move to the slides. So I requesting all of you who are not subscribed yet my channel. So please do subscribe because I'm going to cover all the SDN technologies like SD-WAN, ACI, SD-Access, and all the firewall stuffs like Palo Alto, Fortinet Checkpoint, as well as the automation stuffs like Ansible, right? CI/CD pipeline. Okay. So please do subscribe and please like, subscribe, and comments if you like this series, right? So let's move on to this slide, right? And please focus on this topology. We are going to uh, use this to elaborate this all the terminologies of this SD-WAN, right? So let's consider this the topology, right? So this is the topology. Here we can see the controllers, right? And this is the site, right? So it site can be your office, right? It can be your campus, it can be your remote sites, it can be your data center, right? And these controllers, we know it can be in on-prem, or it can be in on-prem, or it can be in cloud as well, right? So we have controllers, we have edges, right? So we need some terminologies, special terms to understand these SD-WAN technologies, right? So let's start with system IP, right? So system IP is a unique identifier, right? And it must be unique on all routers, right? So let's see here, this the one site one, right? And in site one, we have two router, right? Two edge routers. So in two edge routers, we have to provide a separate system IP, right? So it can be a router ID like in OSPF on BGP, right? It can be a router ID like, and must be unique on per device, right? And it's not be physical as like a router ID of OSPF, right? So it's the virtual IP, logical IP. This is also a virtual or logical IP, right? And it will help to form the DTLS tunnel between the vSmart to this edge routers, right? So it will form a tunnel between the vSmart, between the VH, or between the controllers as well, right? To form the DTLS connections. To form these DTLS connections, the Cisco SD-WAN devices, the system IP, right? Okay, then move to this. One more things to just use this, the why we use system IP to form this tunnels, right? So why we are not using physical IP address, right? So to let's consider the two, right? To BGP, where we have a routers here, right? And they are connected each other with BGP, right? So they are connected with BGP protocol, right? And let's say we have subnet here, right? And one subnet here. So if we want to use redundancy, so we have two routes, right? One route, one path from here and another path from here, right? So why we use here we use loopback interface, right? In router, this router we use loopback interface, and this router we have loopback interface, and between this loopback we will form the BGP tunnel, right? So if this link goes down, so we still our BGP peer will up, right? And we use the secondary link to reach this subnet. So likewise, SD-WAN technology, right, in DTLS system or Cisco SD-WAN now, it uses the logical system IP to form the tunnel, right? So we can use the multiple tunnel, right? If we lose a one uh, transport, we can use another transport and the tunnel will not down, right? Not will not go down. So another is a site ID. The site ID we can consider is path on our traditional BGP routing, right? So AS path should be unique, right? On site, right? So if we have a branch and in branch, you have two BGP routers, right? So what you can do, you will use a AS number, suppose 100, right? And in 100, the both routers will be resides on the same AS number, right? So likewise in SD-WAN, you have site ID. So if you have two or multiple routers or controllers in your site ID one, you have to put, you have to configure the site ID one in all devices, right? So to site as BGP, the AS path will use to loop preventions, right? In SD-WAN, a site ID will be used, it could be used for loop preventions. And another use case of site ID in traditional networking, we use ACL, right? To configure ACL, we use prefix list, right? So we use prefix list. Why? We we need to identify interstate traffic, right? So we identify the interstate traffic, so on which we used to ACL, right? In SD-WAN technology, we use site ID to identify the sites or to identify the tloc where we use this uh, policy or template, right? Or where we use this policy, configured policy to this which sites. So we identify the edge routers with the site ID as well, right? So another terminology, important terms is tloc, right? So tloc is a abbreviations is tloc, right? So transport locator. So in SD-WAN, in traditional networks, we see here this is the MPLS circuit, right? The provider link, and we called is the MPLS link, right? But here is the internet link. We called is the internet link, but in SD-WAN, this link called transport, right? So this is the transport, and in SD-WAN, we want to know the which routers resides behind which tloc, right? So this is the routers and this is the interface. So this is the transport, right? It is also a transport. So if these routers, if want to go to this sites subnet, so it first it need to identify this site is resides on which sites. So it will check the site ID, then it will check the which tloc, which transport is there, right? Whether it's uh, a tloc with MPLS or tloc with internet, right? So the tloc will form including three terms, right? So three terms which a system IP, which color and encapsulations, right? So it also similar to BGP, it use as a next hop, right? In traditional networking, if we want to uh, if we want to uh, provide the route, right? So if we want to provide the route, a subnet, right? And here is a subnet. So this subnet is one to this subnet. So we will provide a route, right? And this route, the next hop would be if this will advertise the network. So to this network to reach this route, it this network will use this router will use this next hop, right? So the next hop would be the pair IP, right? So in here, if we want to 1.1.1 and if 1.1.2 here, right? So we will use 1.1.1 to reach in this subnet, right? So in likewise in SD-WAN, you will this router will use if this router want to communicate if this subnet want to communicate this subnet, so this router will use that this tloc IP as next hop, right? And likewise, if this is this subnet want to communicate this subnet, right? This router will use this tloc, right? This tloc as a next hop. So here a next hop is not an IP of this interface, right? Or this interface, right? The next hop would be the system IP, right? The tloc, right? Tloc, whether it's internet or MPLS. So tloc is the combination of system IP, color, and encapsulation. So let's see, this is the site 1 and this is the system IP, right? So system IP 10.1.0.1, right? So this route, if want to communicate this route, so it will either use this MPLS, right? Or it can use this internet, right? So which tloc means this is the transport, whether it's in MPLS or internet, and the overlay or the tunnel it it can be IPsec or it can be GRE, right? So this is the combination of system IP, color could be MPLS, internet, right? Private, 4G, 3G. So this is the identifier of link or transport, whether it's MPLS or internet or 4G or 3G, right? So it will be identified by this color and the tunnel which will be formed between these routers. It can be GRE or it can be your IPsec. It can be identified by encapsulations frame and the system IP, right? So system IP will be unique. So let's say we have internet link, right? So system IP of this router we consider is 10.10.10.1, right? And the two interface. So two interface, one is MPLS, one is internet. So internet, let's say internet link, but system IP would be same, right? So 10.10.1 and bridge internet and the IPsec would be IPsec. Encryption would be IPsec, right? Encapsulation. Again, for tloc MPLS, we have the system IP same 10.10.10.1 and the color would be MPLS and the encapsulation would be IPsec. Again, if we have a 4G or 3G modem, so the modem would be so that tloc would be tloc 3 and that would be 10.10.10.1. So sorry, it would be 4G, tloc 4G, right? Its name would be tloc 4G and the system IP would be same 10.10.1 and the color would be 4G and the encapsulation would be IPsec. So it can be GRE or it can be IPsec as well, right? So this is the tloc IP and the role of the tloc IP is huge, right? And then again come to this DTLS connections, right? DTLS connections is a transport independent, right? So it can be MPLS or it can be internet or it can be 4G, right? So DTLS connections will be formed with this between these controllers as well as this the routers, right? So DTLS connections would be formed between the edge routers and the controllers, right? Between the routers, the tunnel would be IPsec or GRE, right? So between the routers, there will be no DTLS connections, right? So DTLS connections, again, the DTLS connections between the routers and the V1 controllers would be transient, right? It's the for the time being. So it's just authenticate the router and it get terminated. So and this router will form the tunnel, permanent tunnel between this the smart and the manage, or new name is manager and the smart is controller, right? So this is the DTLS connections. So DTLS connections, if you have two MPLS, two link, one MPLS, one internet, so this router will form the DTLS connections with this V smart and this V manage, right? So there will be two connections, one for internet and one for MPLS. Okay, so if you have three, so it will be three pairs of DTLS connections, right? So if you go to this router and see uh, show connections, control connections, so you will if you have two if you have two transport, you will get two DTLS connections, one with internet and one with MPLS. But OMP pair would be one. So we will discuss when we discuss with OMP, right? So here is bidirectional forwarding and detection. So BFD by default it's enabled, right? No need to configure this. So here DTLS connection is also by default it will be formed. IPsec will be formed by default. There is no need to configure anything, right? BFD tunnel is by default enabled. So BFD is used to, it will mainly function two functions, right? So it used to detect link failure, right? And it will monitor the performance, right? It will determine the application's performance as well, right? So detect the link failure and link performance, right? So uh, detect link failure means this is the your site one site, and this is the another site, right? This is the site 31. It can be branch and it can be remote branch, right? So from between these routers a tunnel will be formed, IPsec tunnel, right? So we know the IPsec tunnel will be formed by default. In between this tunnel, right? Between this tunnel, a BFD sessions will be formed, right? And the BFD sessions we use to detect the link failure. So if this tunnel goes down, it will immediately notify this B manager, right? Or manager, the link, the tunnel is down, right? So one more thing, in the same site, if you have two devices, right? So let's say the site one, we have two devices, right? So between two devices, there will be no IPsec tunnel as well as there is no BFD tunnel will be formed, right? And one more thing here is VPN. We will be cover the overlay routing. So in SD-WAN, we have three types of VPN. So VPN, transport VPN. The VPN is a 16-bit VPN, right? So if you calculate the 2 to the power 16, so you will get 65,535, right? So it can be 0 to 65535. It can be 0 or 65553 in between, right? So the in SD-WAN there is a predefined number 0 for transport VPN, right? So transport VPN means WAN interface. If we consider the WAN interface in traditional network, we already talked about it. So this the transport or link is known as a transport, right? So the transport VPN means the MPLS connections or the internet connections will be connect to this router, and the routers being interface can be in GA interface 1 by 1 or 0 by 0, whatever it is. So this belongs to this interface, one interface or two interface will be belongs to VPN 0 by default. You will not change this number, right? So transport VPN always be 0, and management VPN. So if you have a management switch and if you want to connect the all with this management switch, so the management VPN would be 512, right? It cannot be changed. Okay, and from this uh, apart from 0 and 512, all are known as service VPN. It can be 12511 and 513 to 65535 would be service VPN, means the service VPN. So earlier in earlier video we have discussed in details, right? So you can go and watch that videos. So the LAN interface known as service VPN and WAN interface known as VPN. It resides in VPN 0, and the management interface is known as the management VPN, which is 512, right? So let's come to the overlay route. So overlay routes means these tunnels, right? These tunnels is a overlay network, and the physical link is the underlay network, right? So we are using this SD-WAN mainly to maintain and manage this overlay network, right? So overlay networks, let's see, an overlay routes is only installed. So in like BGP, what we see, if you want to configure BGP between these two sites, right? So the two sides, say, let's say you have a three routers here, right? Let's say one more routers is okay. So this is the IBGP, right? Is running IBGP. So one routes when come to this IBGP, what this IBGP will do, it will forward this route to this, right? And it will not change your next hop, right? So when this router will receive this subnet, it will see the next hop, the of this IP, next hop IP is site 41 IPs, right? Let's say it's a 10.4.0.4. Let's say it's a system IP. It would not be the next hop, right? In traditional networking, right? So if uh, the case is the next hop this IP, and this IP if not reachable from this router, right? So the route which we shared by this router, it will not install in this routing table, right? Because this is the prerequisite to reach this route through next hop, right? So to reachability, for reachability is what we do usually, we run the we run in IBGP, we run the in IBGP we run the IGP OSPF or EBGP to get reachability on devices, right? So in same manner, in SD-WAN technology, if you have a route here, a subnet here, and a subnet here, so this route will be shared via this B Smart early video we discussed, right? So here, if this tloc will not reachable by this tloc, this route which is shared by this router via OMP, via vSmart or controllers, it will not be installed router, this router, right? It will not be installed. So To install the route, we have to reachable this tloc. Okay, so same things is covered here. Okay, and one more terms is overlay management protocol. So this is the heart of SD-WAN technologies, right? And this overlay management protocol is a TCP based protocol, and the protocol number is a same like as BGP, right? And the protocol BGP port number is 179. It added extra two number, right? So it's a TCP based extensible protocol. We will be discuss on upcoming videos, right? So it has formed on between the vSmarts. It form it run between the vSmart and between the vSmart and the edge routers, right? Okay. So this is the OMP, overlay management protocol. Okay, so we will cover this upcoming lecture. So thank you for watching this video, and I'm requesting you to please like, subscribe, and comment for liking this series, right? And uh, please comment for improvement of my video, right? How I can improve my content, right? And please find the link of earlier videos in the descriptions. Thank you again.